Okay, this video we're going to discuss exponential functions. So first of all, an exponential function is of the form where you have a number and then your variable is the exponent. Okay, so in this case we have a to the x. Again, a could be any number at all. And our exponent is our variable x. So there's basically two types. If a is greater than 1, so if this base happens to be a bigger number than 1, then what you end up with is exponential growth, okay, which would come through and then go up like that. Okay, it's exponential growth. If a is between 0 and 1, so think of this as being some fraction less than 1 but positive, then you end up with exponential decay, which would come through and like that. Okay, so you've hopefully heard those terms: exponential growth, exponential decay. It's all based on that value that's being taken to the power of x. So just a quick example of sketching one. I'm going to do this actually using transformations. So I'm first going to graph y equals 2 to the x. Okay, that's my parent function here. All exponential functions will go through the, unless there's a vertical translation, we'll go through the point 0, 1. I'm sorry, any transformation, vertical or horizontal. But 0, 1 will be a point on there. So again, I'm doing y equals 2 to the x. So if I plug in 1, I would get 2. And if I plug in 2, I would get 4, and so on. As I go to the left, I get fractions here. So 2 to the x would look like this. And then what I'm going to do is I'm going to take this function and I'm first going to switch the terms around, and then I think you can see the transformations a little bit better. So I'm going to look at this as negative 2 to the x and then plus 3. So what does the negative do? The negative reflects the graph, and then the plus 3 will move it up 3. So I'm going to take those 3 points that I plotted, just do that with those 3 points, and then graph the resulting graph here. So I've got 0, 1, 1, 2, 2, 4, 3, 8 would be my next one, which I made a little too steep, but I'm going to take those points, I'm going to reflect them, and then move them up 3. So if I reflect that first point down across the x-axis, and then I move it up 3, it's going to end up right here. Reflect this one down, move it up 3, it will end up right here. And then if I reflect that one, the last one down, and then move it up 3, it's going to end up right here. And so what you're going to actually end up with, because this has been reflected, it's going to look a little bit different here. You're going to have a graph that would look something like this. Okay. So then we want to do domain and range of that. All exponential functions, domain is going to be all real numbers. I can plug in any x at all, negative, positive, doesn't matter. I can plug it in, I can take something to that power and get an answer for that. The range we're restricted. So normally the range for an exponential function without transformations is that you're going to get positives, so it's going to be 0 to infinity. Whether it's exponential growth or decay, doesn't matter. Your range is going to be 0 to infinity. You're going to get all positive numbers there. It's going to be above the x-axis. Because of these transformations, that's been flipped. So if it was just reflected, then it would be negative infinity to 0. It would be all below the x-axis. But since then it's been moved up 3, the range is actually going to be from negative infinity to 3 because it has been moved up 3. Okay, so what that's saying is the range is all the y values below 3, which if you look at the graph, that would make sense. I cover all the y's down here, none of the y's above a y value of 3. The next question is just kind of a comparison between an exponential and a power function. So a lot of people tend to get these confused. 2 to the x and x squared, those are completely different. The question is, which one is going to grow more quickly if x is large? So I'm going to go ahead and graph both of those. So we have y equals x squared, and we have y equals 2 to the power x. So as you can tell, they're pretty close when numbers are pretty small, right? So numbers between 0 and 2, their y value is pretty close. But what happens is, for a little bit here, x squared becomes bigger than 2 to the x, right? So for numbers here between 2 and, as you continue on, you can see between 2 and 4, x squared is bigger than 2 to the x. But as soon as you get past 4 here, notice as my x's continue to go to the right, 2 to the x, which is the blue graph, 2 to the x becomes more and more and more steep than x squared, right? So it's becoming a bit of a separation here to where, let me just try to zoom out even more. And again, we're zooming out a lot here, so that difference is becoming even more great as we go on. 2 to the x grows a lot faster than x squared does for large values of x. Okay. All right, last one. A bacteria culture starts with 500 bacteria and doubles every half hour. And then some questions about that. So how do we write an exponential function? Your basic setup is that you have a starting amount, which in this case is 500. Okay, and then your base is going to be the multiplication factor, right? So it's doubling in size. That means this is going to be a 2. If it tripled in size, that would be a 3. Okay, so it doubles in size every half hour. So if it doubles every half hour, our x is going to be the number of hours. Okay, so in order to get one doubling, right, I need to take my x and do what with it? Okay, so some people will be like, well, if it's half an hour, I need to either multiply by 2 or I need to divide by 2. And so perhaps it's maybe counterintuitive to what you would think. I'm going to actually have to multiply this by 2. And now I'll talk about that and why you multiply by 2. So my exponent is 2x. You multiply it by 2 because if I plug in 1 meaning 1 hour, then my exponent needs to be 2 because it has doubled twice in that 1 hour. Right? So if it's doubling every half an hour, it's doubling twice every hour. So that's why I'm going to go with 2x here instead of maybe x divided by 2 might be what you would think, because you're thinking, oh, I should take my hours and divide by 2. But how many times is it doubling in that 1 hour? It's doubling twice. So 2x is going to be my exponent there. All right. So to answer the question B, we've basically done it, but it says after t hours. So I would want to know, like, what is f of t, where t represents the number of hours. So it's basically, we're going to write that function where the independent variable is t and not x. So same thing there. How many bacteria are there after 3 hours? So I want to figure out what f of 3 is, which would be 500 times 2, and then if I plug in 3, I would have 6. So 500 times 2 to the 6th. So 32,000 is what we would get for that. Okay, and then how many bacteria are there after 40 minutes? After 40 minutes. Okay, so we've got to think about, well, what are we going to plug in for x if I want to know after 40 minutes? So what I need to do is I need to relate this to an hour. So 40 minutes out of an hour, which is 60 minutes, is 2/3 of an hour, right? So that means I'm going to do f of 2/3. Should be 500 times 2 to the 2 times 2/3 power. Okay, and then again I'm going to go in and do that here. So 500, 2 raised to the, I'm going to do 2 times 2/3. 2 times 2/3 is 4/3 power. So I'm going to put in 4/3 here. and after 40 minutes, I have right around 1,260. Okay, 1,260 bacteria. Okay, so writing exponential functions given situations, understanding the difference between exponential growth and exponential decay, being able to graph them, all important skills when it comes to exponential functions.